Redefining functions in base class. What does it mean? It means that you know that we are inheriting classes from base classes. So the main objective of inheritance is that actually we want to reuse some code which is already written, but maybe we want to enhance, okay, to upgrade the functionality. Maybe here is some functionality already, okay, so we will use this functionality here by inheritance, but we need a bit advancement to a next level, okay. So due to this reason we will add something more, and maybe it is possible that some function which is here, let's suppose some function here, it is have, let's suppose it has 80, 60, 70% functionality, but we want to add something new, so we will use the same thing plus something more, okay, plus something more. So this is why there is a need of redefining base class functions. Okay, the book has used very nice wordings for that. I just want to show you that one. You see, inheritance is commonly used to extend a class. We want to extend. It means some of the functionality we are using of the base class, but we want to extend to next level or give it additional capability. So the additional capability uh, force us to redefine something, some functions in the base class, in the derived class. Okay, so redefining a function in a derived class that has the same name, not the point, the same name and parameter list. This is a technical definition. You should try to understand, and then you will be able to differentiate from function overloading. Okay, this is function redefining, but we have already studied function overloading also. So let's define again. Function overloading is a function in a derived class that has the same name and parameter list as a function in the base class. So name is the same, the parameter list is the same. So it looks like 100% same copy. The only difference is in the body of the function. There is some more coding inside the body to extend the functionality, and typically used to replace a function in a base class. So uh, I think not fully replaced, because we are using the some functionality from the base one and the new functionality from the derived class. So if, can I ask you, redefining a function is 100% the same function name and the parameter list exactly as in the base class. So when a derived class member function has the same name as the base class function, it is said that the derived class function redefines. Okay, it redefines the base class function. And when an object of derived class calls the function, then it calls the derived class version. Okay, what does it mean? That we have a base class, okay, it has, let's suppose, a function x. Here we derive a class, I will draw like this. We derive another class here, derived class, but this class redefined the function x. Okay, so the name is same, the parameter list is the same. Okay, so the function x is available here also and available here also. So when we create object of class d and call the function x, it will call which function? Which function will be called? Of derived class, because the object is of derived class. As a rule, it is like this. Okay, that when derived class object call a function, it will call its own copy, its own version. And if we create another object of class B, let's suppose, okay, this object, and we call the function x, this time this object will call the its own version. Okay, so it means here is no confusion. The objects goes to their own version, so it is easy to call. The compiler can easily decide that okay, it is derived class object and the derived class version should be called. It is base class object, so base class function should be called. Okay, so another thing that not the same as overloading. You see, I'm repeating for you now. Overloading and overriding are not the same. Why? Because in overloading, the parameter list must be different. If you remember the constructors, okay, we were overloading constructors. Okay, for example, rectangle. Okay, so if rectangle is the class, okay, and then the rectangle constructor, default constructor, and another overloaded constructor will be like this, that here in the parameter list there will be several parameters. Even one is enough to be different from this. So then compiler decides. So you see here compiler is deciding on the basis of arguments that which function should be called. But in the case of function overriding, compiler is deciding on the basis of object. Which object is calling the function? If it is derived class, derived version. If parent class, parent version. But in case of function overloading, the compiler is deciding on the basis of arguments. If you provide arguments, compiler will call this one. If you don't provide arguments, compiler will call the non-argument. This overloading can vary. Maybe one function has one argument, another function has two argument, another same name but three argument. So you see the difference is coming here in the argument, so compiler can easily decide. So just try to understand that here the decision by compiler is based on the number of arguments. Even on the type of argument is also possible. For example, if there are two same functions, but here the argument is int, let's suppose, okay, and let's suppose here the argument is character, okay. So even on the basis on the type of character, still compiler can decide which function should be called, okay. So not the point. The main point is that in function overloading, decision is based on number or type of arguments, but in function redefining, decision is based on the object. So object of base class use base class version of function. Yes, we already talked about that. Any confusion, you can stop me. Okay, this was quite good discussion in the book, so I just copied from there. You see here, there is a distinction between the redefining a function and overloading a function. An overloading function, I think I already explained the same thing for you. Okay, so no need to read. Okay, this is an example. You see here that a grade activity class, it has a function set score. Okay, set score. Now, if we have another class, I will show the coding of these classes. I have already prepared for you. Another class, if the teacher want, you see the previous class was for grading a student. Okay, now sometime we also sometimes actually need that before finalizing the marks, let adjust a bit. Okay, sometimes we also adjusting. So for adjusting the number, maybe we are increasing or decreasing, mostly increasing by some percentage the marks. So for that purpose, there is another class, keyword activity, the curve activity class, and it is inherited from the grade activity. So what this class does, the only difference is here that you see the set score function, but this set score, you see, it has its own variable only using that one also a raw score. You see this one. So first the argument is assigned to raw score, and then this one is the adjustment. That then calling the parent class function, but not passing the argument in the same format as it received, but modifying a bit, modifying by some percentage. So the argument multiplied by some percentage is sent to the parent class, and then the parent class set the score, and later on the basis of this score, the the later will be decided that it is later grade A or grade B or grade C. So you see, this is the redefining that the same set score function is in a parent class also, in this grade activity is there. I will show you once again. Okay, the same function is present there also. You see set score, not this set score function. You see here, and the same function is set score here also. But if you see here is upgraded, redefined in a bit new style. Okay, meaning to say here the adjustment is applied. Okay, so in this way, it redefine the function. And now if an object of third class, okay, will call this one, and object of grade activity class will call its own parent class function. Let me show you this one through an example. I have already prepared this. Okay, I think I should. Okay, so now let's go to grade activity, possible activity. Grade activity. This one. This one. If you see here, here is the score variable and set score class. Okay, from this class we have inherited another class which is called this one. This one. Yeah. Here what we are doing, you see it has its own two extra variables. One the raw score, meaning to say it is not finalized yet, and another one the percentage, that but by what percentage you want to modify or adjust the score. And then you see this one is the constructor. Derived class constructor is calling base class constructor, and then you see the set score function is redefined here. But here you see the argument is assigned to the raw score first, and the raw score is multiplied with some percentage. And here you should learn one more point also, that you see from child class, this one, child class, how to call parent class function. You see the class name, you see from class to class calling is used by the class name, not because we are not in int main yet. Okay, here we are in the class coding, so one class is calling another class, so then the class name will be used with scope resolution operator and the function name, and the argument is passed in some modified way. Okay, so in this case now this can call its own functions. I think I already have its. Yeah, let me find. Okay, now if you look at this, you see this class is included. The modified version is included here, and you should remember that this class is already extended, already inherited from the parent class, which is grade activity, which already has the set score uh, function. Now in int main, just to create two variables, one for storing the score and one for the percentage, that by what percentage you want to modify. And you see here the child class object with the name exam is created. So simple message to get the score and simple message to get the percentage. And after that you see exam dot set percentage first, it will set the percentage, and after that exam dot set score. This is the point. The line number 26 is the main point, that here derived class object is calling the redefined function which is set score. So it will call its own version. Okay, and after that the score is just defined, just displayed again, like get raw score and get score and get letterhead. Okay, if we run this one, it will be like this. Yeah, you see, I hope you can see one class B is inherited from A, and class C is inherited from B. So class C is indirectly inherited from A also, right? So in that case, there is a bit confusion that if let's suppose there is some common class, some common function, let's suppose here is a function x. So due to inheritance, it will come to B. Here B will have this function, okay? And if let's suppose it redefine this one, or maybe this one is inherited from this, so the C got this version also, and the C has its own X also, another one, a redefined one. Okay. Now, in this case, the compiler will call which function. Okay, the situation is like this, that you see, that consider this situation. Let's suppose I have explained this thing very nicely in my previous video also. I hope if someone have watched, maybe they can remember that class. Let's suppose we have a base class, and this base class is defining a function x and another function y. But the x calls the y. The x calls the y. Now, a derived class inherits from this base class and redefines the function y. Okay, so now the derived class has 2y. Okay, it is something like this, base, so x function and y function. These are two functions are here. Okay, now a child class derived from this one, this redefine the y class, the y function again. But due to the inheritance, the x and y are actually already here, because these are public functions and the inheritance is public. So the xy functions are already here. So now the child class got 1x and 2y, not the point, 1x and 2y. So when the object of this child class, if I say like this, child class obj, it call the function x. Okay, it call the function x. Okay, it will go and will call the function x. But here is a problem that you see the x is calling the y. Now this x will call this y and this y. Okay, so this is the challenge and this is the problem in multiple inheritance and redefining a function. It may be possible from multiple inheritance also, and it may be possible by redefining function also. So this situation can be created in both cases, if you redefine or if you have multiple inheritance. In multiple inheritance, maybe one class is inherited from two parents, okay, from two parents, okay. So if this one has the function y, okay, and this one also has the same function y, okay, the child will get 2y, okay. Now, if the child class object is calling the y function, so here are two, which function will be called? It is a bit explained in further detail in this one. It is like this, you see. The base class has a function x and y. These two functions are here. The child class redefine the function y. So the child class object, which is D, it calls the x, but the x is calling the y. Okay, but not the point due to inheritance. These both already came here now. Okay, so x is here also because of the inheritance, and y is here also. So the x, the d object, which is child class object, it calls the x function, so it will call its own version here. Okay, but the problem is that the x is calling the y, but here are two y's. Which y will be called? So here the confusion comes in. So the object d calls the function x, as I told you, and the function x calls the y in base class. Okay, it will call the base class, not the function y in child class. Okay, why? Because functions calls are bound at compile time. Did you get what I mean? I am repeating. The main critical point is this one. The question was that which function will be called. The decision of the compiler is like this, that you see the d, which is the child class object, it calls the function x. So function x is basically from parent. Okay, it is basically parent class function. The child only got through inheritance. Okay, so when compilers see, you see the inheritance will actually occur when the program actually runs. Okay, during compilation time, compiler can only see the x in parent because here is hard codedly written. Here it will come when the line of inheritance is executed. So meaning to say this coding will come here later, not during the compilation time. So compiler decide in advance that okay, the object will call the function x, which is in parent. Okay, which is in parent. Okay, the parent version. Then the parent version x is calling the parent version y, not the child version y, because compiler only see during compile time the x and y. Okay, this inherited two is not visible and is not existing during compilation time. So the compiler decide and make the bindings. Bindings, okay, this is actually called bindings. Compiler bind this call with this one. Okay, even if it is, if you think like this, that I first draw here, my point was that it will call the parent class function, which is x. Okay, so compiler will bind that whenever this line is executed, compiler will run the parent class x, and in the coding of parent class x there was a call to y. So it is already defined, it is already decided by the compiler that okay, as a definition, the child class object is a type of, if you remember the is a relation. Okay, is a relation. For example, if I told you that like the hornbill is a bird, okay, undergraduate is a student. Okay, so this D is also a type of the parent class, so it will call this, and the X is calling the Y. Okay, which is actually not expected. The child class object we expect, why we redefine, because we need extra modification. But when we call, we will not get the modification, it will call only the parent class y, not the child class y, because the reason is static binding. Static binding means that when the compiler decide or bound or decide at compile time. This is called static binding. I am quite sure that you are somehow confused. Am I right? So I should give a name, uh, let binding. Okay, let or static binding. This is also called let binding or static binding. Bind dot cpp. Okay, I will define everything in this class. Okay, let's define a class. Uh, First of all, can I copy something from here? String, this one, this one. You see, the programmers are so lazy. I don't want to even type this. Okay, no problem. Class uh, base uh, base class. Okay, and this base class has. Okay, I'm just defining functions to clarify the concept. Okay, let's do the same scenario. Okay, uh, public void x. Okay, void x, and inside this x I am calling y. y I'm calling the y function. Okay, pilot give me an error because there is no y here. I will define void y. Okay, and here I will simply type cout. This is base class y function. Okay, this is base class y function. Should be okay, right? Now I am inheriting another class, not like this. We are not that much smart yet. Class child class. This child class is inherited publicly from base class. Okay, from base class. And this base class redefining the y function. Okay, this should be public function. I skip the private section. Okay, so I am just copying this, but modifying the this coding here. This is the child class. This is the only difference, right? Child class y function. Okay, let me know until this point. I don't go ahead first. If you don't know until this point, then the confusion should be clear from here. Is it okay? Okay. Okay, good. So if until this point is clear, then let's come to int main. Int main. Okay. And inside int main, I will create child class object. Okay. Child class object. I should call obj. Okay. And after that, I will call obj dot x. Simply to be very simple. Now you see when now if I compile, uh, unfortunately compilation is not simple compilation is not available here in dev C++. You can compile also and you can run also. So when you only compile, if you don't run, then compiler see what that you see obj, which is child class object. Okay, no problem, but it is calling parent class function. Yes, a compiler will say okay, you can call because it is inherited from this, and the child is a relationship. Okay, the child is a type of the base class. So can okay, you see now compiler decide this x only here, because compiler decide on the basis of writing here. Okay, because you see the byproducts, the intermediate results will only occur. The inheritance, I call the intermediate result. The intermediate result, to copy these two to the child class, this will be only copied, only inherited when compiler really runs this line. Okay, when actually runs this line. Before running, compiler only see that X is here. Then from now decide that, okay, I will call this parent class X. And you see, parent class X is calling Y function. And parent here in this X, in parent X, it will of course call parent Y. It cannot call this one because you know the accessing from parent to child is not allowed. Okay, it can only call child class. So now when the compiler decide now, then the binding is like this, that compiler will bind this calling to X, that okay, when I really convert to machine to binary code, okay, then I will do like this. And this X will call this Y function. So this decision is done at the compilation time. So when we run, then compiler go through the decision that already has been done. We will never get this thing that we accept. So if we never get this one, then its definition become useless. We are not getting the enhanced version, the modified version. We will never get. Okay, let me show you. Okay, so let's run this one. Let's Oh, already there. This is base class Y function. It never calls. You see, it will never ever call. Why? Because after compilation, the situation here, the situation in the child class actually become like this, that the child also got X, okay, and the child also got one Y because of the inheritance from parent. These two are from parent, okay, and the child has its own enhanced version Y. So this X is calling Y. So which Y? Compiler only decide at the beginning that I will call this Y. Okay, because the child scenario will only created after executing and really converting to machine language this line, but the compilation occurs before execution. So the compiler decide like this, and then from here like this. So when the running times comes, compiler just follow the binding. Okay, this is called binding. Just follow the binding which has been done during the compilation time. So it's a big issue. We want some new thing, but we cannot get. This behavior happens because the way C++ matches the function calls with the correct function. This process is known as binding. In program this we didn't run this one yet, but we run our own one. C++ decides at compile time which version will run, okay, to execute when it encounters call to the function, even though we pass, yeah. Okay, so you see this is here it defines the process. Okay, so this problem that the compiler decide at compiling time, it is called static binding. So how to solve this problem? What will be its solution? The solution for this is the virtual function, okay, virtual member function, and that is called dynamic binding. We will force the compiler to don't do static binding, do dynamic binding. So what is dynamic binding? Compiler will not decide which function will be called until it really execute the coding. Okay, so how to do, and what will be the procedure for that? For that purpose we need a special function which is called virtual function.